So, very good morning, students. So, welcome to IIT NEET Foundation or Focus C program by Krishnaveli Talent Schools and the Mastermind Schools. So, once again, welcome all the participant branches so far, along with your class 7th students for today's session. As you all can see on the screen, and you are well aware, so my subject is physics. We are in class 7th. Our ongoing chapter, our new chapter, that is the last chapter of this academic session, the chapter number 8, Gravitation. Today we are in the session number 1. So far we completed 7 chapters and already attended 7 tests. So this is the last chapter for the academic session from the material, which we are going to complete by end of this month. Then we'll have the test number 8 followed by grand test in the month of March, right? So today we are going to discuss about the very interesting topic, gravitation. So what we'll get when gravitation is nothing but force of earth, right? Force of earth. So whenever you recall the gravitation, what we'll get is idea. First one is apple tree. Second one is Newton. These are the only 2 things we get in the mind when you are discussing about the gravitation. That is, whenever Newton sat under apple tree, apple fallen down. From that simple concept, he developed a huge branch of physics called gravitation, right? So it's simple because before Newton, so many persons might have sat under the apple tree, but nobody observed that. But this person observed that why it is falling down, why it is not going up or staying there. With that simple thought process, he developed the gravitational force or introduced the gravitational force or gravity, right? So Newton under gravity. Based on that, there is a big branch of physics is developed, which we are going to discuss in the coming 3-4 classes, right? So you can see in this chapter what we are learning. You can see here. First, we're learning about what is gravitation and gravity. Then acceleration due to gravity. What are the factors influencing? Then Kepler's law of gravitation, which is related to planetary motion. Newton's law of gravitation for about Earth. Kepler's law of gravitation about the gravitational force of other planets other than Earth. Sun, Mars, Jupiter, right? All this, study about all this comes under Kepler's law. So like that, in coming 4 to 5 classes, we are going to discuss about the entire chapter of gravitation, right? So here we start with the introduction part, synopsis 1. So when you see synopsis 1 here, about so what is gravitation and what is gravity? To see, the earth attracts or pulls all the objects towards its center. You would agree or not? Whenever either you are throwing the body upwards or dropping down, it is always pulls the body towards itself. Even though it's thrown up, after some distance, it will come back and attract it towards the earth. That is the first point. The force with which earth pulls the object towards itself is called gravitational force of the earth, right? So earth pulls all the bodies, all the objects towards itself, whether it is thrown body or whether it is dropped body. That force of earth is called gravitational force, right? Or gravity. It is also called gravity. Gravity of the earth. Short form, gravitational force is nothing but gravity. It is due to the gravitational force of the earth that all objects falls towards the earth when released from the height. Suppose I drop in the pen. So how it is coming down? Because of the gravitational pull, because of the gravity. Okay, then. So the gravitational force of the earth or gravity of the earth is responsible for holding the atmosphere above the earth, for the rain falling to the earth, and for the flow of water in the rivers. It is also gravitational force of the earth which keeps us firmly on the ground. So because water is falling down, how it is falling down? Because of the gravitational force. Flow of the water, or you are standing on earth because of the gravitational force. When you jump, again you are pulled back. All these things because of the gravitational force, which is the nature's force, right? So there are so many things are there with which you can have the gravitational force. Okay. Then gravitation, short form of that. Every body in the universe attracts other body with a force known as force of gravitation. When you are keeping two bodies separated some distance, it may be small bodies or huge bodies, no matter. These bodies attracts each other with some force, and that force is called gravitational force. What is that called? Gravitational force. The force between any two bodies means every body in the universe attracts every other body with a force called gravitational force. Right? So gravitation is the force of attraction between any two bodies in the universe. The attraction between the sun and earth, the attraction between the table and chair lying on the floor, room, the attraction between the earth and satellites revolving around, etc. are the examples of gravitation. So all these are possible because of the gravitation. Earth is revolving around the sun because of gravitation. Moon is revolving around the earth, that is satellite, is a gravitation. Earth and table firmly standing on the earth because of gravitation. All these are the comes under the examples of gravitation. So based on this only, the Newton proposed the one law. So before going for that, I'll show you one video showing about the gravitation, right? Just introduction video, introduction part of the gravitation video. Let's see. Just a minute. So gravitation is a very important part of the earth force, without which you cannot even imagine even standing on the floor also. We cannot even stand on the floor without the gravitational force. Okay. There are so many videos explaining about what is exactly how the body is attracted towards the gravity. Okay, just a minute. We'll go through that video and then we can understand what is the gravitational force. Even space, when you are going on space also, you can find the gravitation. Every between the two bodies, whether they are the
gravity
celestial bodies.
For kids. Have you ever heard of the saying, what goes up must come down? This is talking about gravity, which is what we are learning about today. So, what is gravity exactly? Gravity is the force that makes everything fall towards the Earth or towards other planets or other objects in space. Gravity, or gravitational force, attracts all objects toward each other. It is the force by which a planet or other body draws objects to its center. And it is gravity that keeps the planets in orbit around the sun. Without gravity, you would literally float off into space. Every object in the universe has something called mass, which is the amount of matter in an object. The size or pull of gravity depends on the mass of the objects. Mass is not the same as weight, because weight can change. Mass never changes. For example, Your weight on the moon is different than your weight on Earth because the gravitational pull of the moon is different than the Earth's. But your mass remains the same, no matter where you are in the universe. Here's an interesting fact. You exert a gravitational force on people and objects around you. But the force is not very strong. This is because you are not as massive as the sun, Earth, or moon. But the next time somebody tells you to use the force, you can say, I already am. Because you are experiencing and exerting gravitational force all the time. Remember
All these are the
this.
example where you can
The
find the
bigger the
gravitation,
mass, the greater the gravitational force. This is why all of the planets in our solar system revolve around the sun.
See,
The
because of
sun is
that only
so
they are
large
revolving.
compared to the planets that each planet is pulled or attracted to the sun as they orbit around it. Let's look at an example. Do you think that someone who weighs 100 pounds on Earth would weigh more on Jupiter or on the moon? If you said Jupiter, you're right. Since Jupiter has more mass, its gravitational pull is greater, which means that someone who weighs 100 pounds on Earth would weigh 253 pounds on Jupiter. On the moon, they would only weigh 17 pounds. Here's an interesting fact. Gravity gets weaker with distance. The closer the objects are to each other, the stronger the gravitational pull will be. Did you know that the gravitational pull of the moon is what causes ocean tides? It's true. There is a swell or
Many interesting
increase in
facts about
sea
the
level
gravitation.
as the moon passes over the ocean. As the Earth rotates, the moon passes over new parts of the Earth, which causes this swell to move. And gravity is what keeps the air around the Earth from drifting into space. It's what holds down our atmosphere, which allows us to survive. Gravity also causes hot air to rise and colder air to fall,
See,
which creates wind. Who knew that gravity was so important to our life here on Earth? Science is so cool. How do we know so much about this invisible force?
invisible, we cannot
We
see
can
that.
thank two famous scientists who discovered, researched, and experimented with the concept of gravity: Sir Isaac Newton and Albert Einstein. First up is Sir Isaac Newton. He studied the work of other scientists and realized that gravity was a force of attraction, and that the size of the force depended on both the mass of the objects and their
A
distance
very important point. That force depends on the mass of the objects and distance between the objects. When distance increases, force decreases. Right? When the mass of the body increases, force increases. So gravitational force is different for Earth, different for Sun, different for Jupiter. As the Jupiter is heavy mass, the gravitational force is more. Right? When as the Moon is less, gravitational force is less. Right?
from each other. Sir Isaac Newton
See, just there is a technical issue I told. That
is the scientist who watched an
sat under
apple
apple
fall
tree.
from a tree and realized that there was a force at work. Newton wondered why the apple falls straight to the ground and not sideways. He realized that the force that makes objects fall to Earth and the force that keeps the planets in their orbits are the same force. Newton's law of universal gravitation was published in 1867 and states that every celestial body in the universe attracts every other celestial body. This attraction is due to a force, gravity, that depends on the mass of each body and on their distance from each other. The force of gravity between two objects increases as their masses increase. In other words, the greater the mass, the greater the gravitational force. Also, the gravitational force between two objects decreases as the distance between them increases, which means that the farther away two objects are from each other, the less gravitational attraction. The closer two objects are, the greater the attraction. Newton also discovered that two objects, regardless of their masses, will accelerate or fall equally if dropped from the same
Very
height.
interesting observation.
For
I'll
example,
explain next class.
if you drop a brick and
See, when
an
you're dropping the
apple
two
from the
objects,
top of a building,
both will
both
reach at
will
same
hit the
time.
ground at the same time. Another famous scientist, Albert Einstein, discovered that gravity not only pulls on mass, like a
So some technical problem is
planet, but also on light. A flashlight shined into the air will grow redder as gravity pulls it, though you cannot see the change with your naked eye. Here is a final interesting fact. A black hole has so much mass in such a small volume that its gravity is strong enough to keep everything from escaping, even light. Black holes have the strongest gravitational pull in the universe. And scientists have only scratched the surface of studying them. Maybe someday you will be a scientist who discovers even more about gravity. Okay, our brains are full of new and exciting information. Let's test our knowledge. Fill in the blank. Two famous scientists who discovered and researched gravity are Sir Isaac Blank and Albert Einstein. Newton. True or false? The closer two objects are to each other, the weaker the gravitational pull. False. Gravitational pull increases when objects are closer together. What celestial bodies have the strongest gravitational pull in the universe? Black holes. Great job, everybody. Gravity is all around us. Even when we're not aware of it, it literally keeps our feet on the ground.
We are coming back to the
and is a vital part of our planet and universe.
So many examples.
The next time you see an apple falling from a tree,
gravitational force and gravity. Okay, the total about the gravitational force explained by, it is initially started by the Newton, then joined by Albert Einstein, then by the even Galileo also had the role in it, identifying the gravitational force. But Newton developed the gravitational force by using the universal gravitational law, or you can say, see here, the universal gravitational law is the law proposed by Newton. What he observed is, suppose when you taken the two bodies of masses m1, m2, and they are separated by some distance r, right? So two bodies means is told that every body in the universe attracts every other body with some force, and that force is called gravitational force F. So what he thought is, this F is directly proportional to product of their masses. Equation 1 means whenever the masses product increases, product means either m1 increases or m2 increases, automatically force increases. Similarly, this force is inversely proportional to square of the distance between them. When the distance between the object increases, force decreases. So from these two only get the law, F is proportional to m1 m2 by r square, or it is also as F is equal to capital G is taken as a constant in place of proportionality symbol, m1 m2 by r square. This G is the called universal gravitational constant. What is it called? Universal gravitational constant. So very new thing introduced, that is constant for every body, whether it is a earth, whether it is a moon, whether it is a sun or Jupiter. So what is G? You can write here, G is equal to, bring everything this side, F r square by m1 m2. This is a formula for G. You can get the value of G. So the G value is given by 6.67 into 10 power minus 11 Newton meter square by kg square. This is a universal gravitational constant, means the value is constant entire universe. This value is constant for Earth, Sun, Moon, Jupiter, Mars, whatever bodies you are taken. The capital G value is constant. That's why it is called universal gravitational constant, which is absorbed from Newton's gravitational law. Right? So, in details, we'll discuss in the next class. You can see on the screen also same formula. What are the units of that? Okay, this is the formula derivation when the two bodies are kept. Means, no doubt, Earth attracts every body towards itself, center of the ball. That is called gravitational force or force of gravity. This force of gravity depends on only two factors. One is mass of the bodies, and second one is distance between the two bodies. If the mass of the body increases, force increases. If the distance between the bodies increases, force decreases. Based on that, we got the formula F is equal to capital G into M1 M2 by R square, where the capital G is called universal gravitational constant. Right? That is called universal gravitational constant. Okay, so in next class we'll discuss in deep about this law and also discuss about the further topics, acceleration due to gravity, and followed by Kepler's laws of motion. Right? So there are a lot to discuss here. Very interesting things about the Earth gravitational force, which we can see directly, you can experience when you are walking, when you are jumping. On us also, the gravitational force will act. Without that, we cannot even imagine also. Not only our Earth, even planets. Every planet you can see here. Kepler's laws. Purely about the planets. Okay. So you can see the home task, homework for today. State and explain Newton's gravitational law. Right. That is Newton's law. Tomorrow, once again, I will explain that. So that's all for today. Due to some technical issue, delayed by 5 minutes class, 5 to 10 minutes. No issue, we'll cover it in the next classes. As you all know, this is the last class. Okay. So that's all, students. Thank you very much. Have a wonderful day. Thank you.